In this video, we'll look at transformations of functions, vertical and horizontal shifts. So we'll talk a little bit about transformations of functions generally, and then we'll go into vertical shifting and concluding with horizontal shifting. So when we talk about transformation of functions, what we mean is that we're taking some function f of x and moving it around the coordinate plane. In this video, we'll look at the vertical and horizontal shifts and transformations of a particular function. Later on, we'll look at more of vertical stretching and shrinking, horizontal stretching and shrinking, and a few other kinds of transformations therein. So to begin, suppose that we have a function f of x equals the square root of x. First, let's graph this. So we should have we've got the square root, which we know should start at 0, right? If we plug in 0 for x, we get 0 back out. We can take the square root of 0 since 0 squared is 0, so we will plot that point. What about the square root of 1? The square root of 1 is just 1 by a similar logic. So when we plug in 1, we get 1 back out, right there. What about the square root of 4? We know that should be 2. So we move 4 along the x-axis and then 1, 2 up, land us there. And we could go on, but we know that it looks something like this. That's the square root of x. Now let's say that we want to move this vertically upward. And what I want to ask you all to consider is, what are we actually doing when we're moving a graph of a function upward? What are we changing about the graph? Well, we'd be changing all of the y values. So, for example, I can just cut this, grab it, and I could just move it up slowly, like that. So I'm changing all the y values, but keeping all of the x values. In other words, I could grab every coordinate pair x, f of x, and change all of the f of x's. So now we have x, f of x, plus or minus some number, let's say c. So in this case, it's going to be plus because we're adding some positive number to move it upwards. Like in our graph here, we started at the y value 0 at the point 0, 0, and then we added 2 to the y value, so now we're at 0, 2. 0, 2 is this point. This one was 0, 0. Similarly, this coordinate pair here, that's 1, 1. If we add 2 to the y value, we move it up 2, and now we have 1, 3. So in this particular case, we've moved it up 2, so we take all of the x, f of x coordinate pairs, and we add 2 to the y values. Vertical shifts of graphs. So suppose that c is greater than 0. To graph y equals f of x plus c, shift the graph of y equals f of x up c units. To graph y equals f of x minus c, shift the graph of y equals f of x down c units. This is the same idea that we were just talking about. Basically, we're taking every coordinate pair, x, f of x, and adding something or subtracting something from the y value, the f of x value. And that should make sense by the definition of a graph, right? The definition of a graph is the collection of all coordinate pairs x, f of x in the domain and range of a function f. Moving on. So again, let's suppose that we have f of x equals the square root of x, because this is a pretty good one to visualize, a pretty good function to visualize what's happening when we're doing shift and translation. So again, we have the coordinates 0, 0, we have 1, 1, 4, 2, and our graph looks something like that. Previously, we were shifting vertically up and down by adding and subtracting y values from the f of x, right? We have a graph is every coordinate pair x f of x, and we connect those, and that creates the graph. So if we move something up or down, we need to change the y value without changing the x value. If we want to move it horizontally, left or right, that's a little bit different. So let me move this over. So suppose we are shifting the graph of the square root of x to the right some number of units. So we start with 1 unit, 2 units, 3 units, 4 units, etc. So now it's a little bit different. We're changing the x values for the same y value, which means to get the same y value out, we will have to change the input and then give that changed input to the function to get that same y value. If we want to get 0 out from 4, what do we need to do to 4? Well, we need to subtract 4 from 4, so when we take the square root of that, we still get 0. And similarly, if we want to get the y value of 1, but now we're moved over some, we need to subtract 4 from 5, so when we take the square root, again, we get 1. So with the vertical shifts, we took our x's, the same input, but changed the output. We added or subtracted some c value to move the graph of f up and down. So now for horizontal shifts, we need to take our x value, and when we feed it to the function, we need to subtract enough to get back to, quote, the original function, in the sense that the square root is the original function. That is, we have the coordinates x, f of x minus 4. So that gives us x minus 4. If we are 4 units along the x-axis, but we still need to have 0 as our output, we need to take 4 away from 4, so we get the square root of 0. And similarly, if we're 5 units along the x-axis, we need to take 4 away from 5, so we can get back to 1. So we give it an x, and we subtract the number of units to stay at the same y value. Notice that the effect of this is if we have a minus 4, we move to the right. You can think of it similarly if we move to the left some number of units. Suppose we're over here at like x equals negative 4. Now we have to add 4. So if you see a plus sign, that should make you think shifting left. If you see a minus sign, that should make you think shifting right. So now with this function that we have to the left here, this shifted square root function, this will be now the equation g of x equals the square root of x plus 4. So f here represents the base function in a sense, and then we shift it over 4 to the left. So we could say f of x equals the square root of x, and then g of x equals f of x plus 4, which equals the square root of x plus 4. So we can kind of think of our shifted function in terms of our base function. So horizontal shifts of graphs. Again, suppose that c is greater than 0. To graph y equals f of x minus c, shift the graph of y equals f of x to the right c units. That is, when you see a negative sign, x minus something, we're going to the right. To graph y equals f of x plus c, shift the graph of y equals f of x to the left c units. In this case, you can kind of think of it as a f of x minus negative c. That is to indicate, like, if x minus whatever is the standard form, and we can grab a positive c from that. If we see an x minus a negative, that should tell us that we're going in the negative direction. So let me just write that. So if we have like y equals f of x minus negative c, that tells us that we're going to go in the negative c units to the left. In the previous case, f of x minus c, right there, that just tells us that we're going c units to the right. So then minus is the standard form, so we need to look for c or negative c, that is f of x minus c or f of x plus c. Next, we'll look at some other transformations of functions. In particular, we'll look at vertical stretching and shrinking.